Thank you for your interest in our recently published paper titled Increased Susceptibility of WHIM Mice to Papillomavirus-Induced Disease is Dependent upon Immune Cell Dysfunction. WHIM syndrome in human patients is a primary immunodeficient disease caused by dominant mutations in the cytoplasmic tail of CXCR4 receptor, resulting in impaired desensitization and enhancement of CXCR4 signaling upon ligand binding. Human WHIM syndrome patients are extremely susceptible to papillomavirus infection. There are several CXCR4 antagonist drugs that are under clinical trials for treating WHIM patients, but there is no curative treatment to date. Using WHIM allele mutant mice and mouse papillomavirus as an infection model, we have demonstrated a single CXCR4 mutation present in WHIM patients confers the susceptibility to low-dose mouse papillomavirus infection in FVB mouse strain. Mouse papillomavirus-induced lesions have a higher incidence of high-grade dysplasia and cancer in WHIM mutant mice. Papillomavirus infection increases circulating immune cell counts in wild-type mice, but this increase is greatly diminished in WHIM mutant mice. To explore the contribution of CXCR4 mutation on immune cells alone, we transferred bone marrow cells from WHIM mutant mice to lethally irradiated wild-type mice. We found that wild-type mice who received WHIM mutant bone marrow cells have decreased the circulating immune cells and increased susceptibility to papillomavirus infection. And transfer of wild-type bone marrow to irradiated WHIM mutant mice rescued their disease phenotype. Our data support an important role of WHIM mutation in immune cell dysfunction and susceptibility to papillomavirus-induced disease. The WHIM mutant mice can be a powerful preclinical model for human WHIM syndrome to test the efficacy of new drugs and to find a curative treatment for papillomavirus-induced disease in WHIM syndrome.